So you've seen our videos about Subaru engines blowing up and why they blow up, how to build engines that don't blow up, how not to blow up your car. When you see all these, you might have the impression that Subarus are pieces of crap and they blow up when you just look at them sideways, but that's not necessarily true. You might be wondering about how we personally build Subarus and what kind of reliability can you expect out of them. Well, behind me is our shop car. This is a 2005 STI that we've totally built here. It's my daughter's daily driver, but we have it at the shop here. It acts like a demo car for people that are curious and stuff like that. And it's kind of what we feel is the ideal way to build a Subaru that could be an all-purpose car. You can daily it. You could run it hard at the track. You could do actual track days. Run both days, every session. Not worry about it blow up and have it drive home. There's been a lot of talk about all this, but Subarus aren't like just total grenade cars, and this is an example, and this is kind of what we did. So you might be a little curious about the engine, for instance, because that has perhaps the worst reputation of Subaru things. Well, in our other videos, we talked about reasonable expectations, and to us, that's keeping your engine at about 550 horsepower or slightly below. We feel that this is kind of the happy place for a reasonably modded, reasonably not super exotic built EJ. Sure, we can build you an 800 horsepower engine or a 1,000 horsepower engine, but there's always going to be caveats at that. Like maybe you can drive engines like that on the street. Maybe you can do some quarter-mile blasting, but unless you want to spend a lot of money and worry about replacing engines now and then, I probably wouldn't recommend you taking them on the track to do track days or time attack or road racing. Those engines can hold, but it's outside the happy zone of the EJ unless you start getting into really exotic stuff. So, keep it at the happy spot, 550 and below. The other thing about those big horsepower cars is that more power, more heat, and it starts to get really difficult to manage the heat and keep any semblance of a street car. You have to get a really huge custom radiator, huge oil coolers, maybe a dry sump, and it's hard to get that all to fit and keep your air conditioning and all your daily driver niceties. The other thing is, when you're at 550, your drivetrain is all good. You get a good solid twin disc clutch, and the stock transmission, the 6-speed anyway, not the 5-speed, holds up fine, and your axles generally don't give trouble, and your diffs and all that don't give trouble. When you start getting to the big horsepower guys, you start breaking axles, maybe you break the transmission, it starts to spiral and get more and more expensive. Sure, you can get a race-style dog box and all that, but on the street, those are high-maintenance items. They won't break, but you have to take them apart and dress the dogs and all that, or they won't shift, and the dogs and things wear. So, although you can drive one on the street, they're not necessarily the most low-maintenance thing on the street. The other thing to consider too is when you get really big power, you need big turbos, and big turbos mean more turbo lag. You also have to run a lot of boost to get up there, so like fueling is a problem. Now with E85, it's not as much of a problem, but if you're running like on a pump gas tune, it's going to be a dog until you put E85 there. Even with E85, you're going to have turbo lag, and it's not going to be the most pleasant, responsive thing on the street. Sure, it's doable, but like a car that has no power below 4,500, kind of sucks as a daily. So our car here was kind of built to not give up anything over stock. So it has stock-like drivability, stock-like levels of turbo lag, but you know, just way more power, almost twice as much power as stock. So basically, the engine is a collaboration between us and IAG. We're using as a foundation IAG cases. We think they do a great job of building their cases. Everything is precision CNC machined on fixtures, especially to accommodate Subaru's notorious distortion when you torque them up with studs and things like that. The case is converted to closed deck using IAG's cast inserts. The cast inserts are cool because their expansion characteristics match that of the cast case, so you're not going to get any weird distortion due to the inserts under heating and things. The case is bored for big studs. You know, we're using big 12 millimeter ARP. You know, and it's all machined with studs to, you know, avoid any of the distortion. The block is also O-ringed, and we're running O-rings with the stock gaskets. So we're not likely to have any kind of head gasket issue. The bottom end, we're running a stock '06 and later crank. Now these cranks are our favorite to run also, like they're nitrided, and that gives a hard finish on the journals that it's not likely to wear so easily. The stock crank's not that bad. It can hold up to 800 horsepower. So, you know, we're not going to have any problems. The connecting rods are Cali's connecting rods. They're longer than stock, and they're running the ARP 625 custom age bolts that are quite a bit stronger than your standard ARP 2000. We're running the IAG JE pistons. So what's different about these over your regular JEs is that the pin is moved to accommodate the longer rod. The quench area of the piston matches the quench area of the head better. You know, we talked about that in our last video, so you get more combustion turbulence and less likelihood of detonation. The alloy is 2618, so it's a low silicon alloy. So that's nice and tough, the best thing for turbos. IAG uses nickel plating on the skirt instead of like coatings and things like that. The nickel plating is hard and slippery, so less friction, longer life. The dome is also nickel plated, so that also gives some protection against heat and detonation. And the nickel plating is in the ring grooves, which also helps the ring grooves have longer life. So IAG with a longer rod, we talk about stroke to rod length ratio a lot in our videos. The longer rod gives more time to fill the cylinders because you have more dwell time at top dead center. You have better angularity, so you have less dig of the piston into the cylinder wall. So you have less wear and more better mechanical efficiency, less mechanical losses. You know, it might give you a little bit less bottom end, but that's not really too much of an issue. Overall, it's a good deal, and you know, we're able to get the slightly longer rod and keep reasonable ring package spacing. We're running King bearings in the bottom end, the XPC coated bearings. We've had great luck with those. So overall, the bottom end is pretty stout, but it's nothing fancy like a billet case or anything, and so it's kind of reasonable. You know, it's solid but not super high tech. We're also running the IAG oil pump. This oil pump flows about 15% more than stock and has about 7 or 8 pounds more pressure. With Subarus, you know, they have like their oiling issues, so that is never a bad thing. The oiling issues are not usually due to the pump. They're usually due to running low on oil, getting puked out and stuff like that. But you know, having more pump never hurts than a performance motor. The oiling system, we're running an IEG pan. We really like their pan. It has all these one-way trap doors, so the oil can go toward the pickup but not away. We're also running an IEG windage tray. We really like this too because it also has one-way trap doors, so the oil can't splash up and get into the crank and cause a lot of windage to get puked out the breathers, like which is typical on these boxer engines. You know, so like our oil is going to tend to stay in the pan and not fly around so much. We're also running Knight Motorsport billet valve covers that have built-in air oil separators that are a lot more elaborate and trap more than the factory air oil separator that's kind of rudimentary that is in these motors. So we're trying to do everything we can to keep the oil in the pan. So good solid bottom end, good oiling control, nothing exotic. We're also running the IEG pickup too, so we don't have to worry about that fracturing or breaking and causing a bad day. Our cylinder heads are the IAG CNC ported heads. They work to try to get the flow even between the front and the rear cylinders. We talked about that infamous dogleg robbing the front cylinders of exhaust flow. CNC porting is good because it has really good consistency. We're running SuperTech valves, stainless on the intake, Inconel on the exhaust. Inconel is good because it's really heat resistant. We're running 1 millimeter oversize. We just did that because this is a fairly hot engine. We're running GSC valve springs and titanium retainers and GSC their number 2 cam. This is like a medium cam. You know, it's a fairly aggressive, but you know, still streetable. We have a slight low P idle due to that, but you know, it's not too bad. And with some tuning of the variable cam timing system, we didn't really lose that much low end power. To clear the cam lobes, IAG notched the heads where the cam followers go for more lobe clearance. That's about what we did with the cylinder heads. You know, overall, the lawn block is not exotic, but you know, it's a pretty solid deal. It has the potential to hold up to 800 horsepower, although you know, it's kind of our opinion that its happy place is 550, and you can pound on it at that point, and you know, it's still going to last you a long time on the street. So, you know, that's our advice. We did some things on the engine, like we're running a MXP equal length header. We really believe in running equal length headers on these motors. Like, they don't have that cool Subaru sound. It almost sounds like a normal car, but the equal lengths do make more power, and they do have a broader power band. So, you know, when it comes to function, you know, we prefer that over having the Subaru sound. I know a lot of you guys love the Subaru sound, but we're more interested in efficiency. Now we're running a stock position turbo. That's because it just fits in the engine bay better. It has better thermal management, and it kind of you know, looks a little bit more stock, which is kind of important in California. We're running a precision drop-in ball bearing turbo. They have 2 with different size wheels. We're running the bigger one. We've run both turbos, the smaller wheel and the bigger wheel. Bigger wheel makes a little bit more power, causes a lot less charge air heating, and we couldn't even tell any difference in lag really. So on a build engine, you always want to go with the bigger one. We're also running a Cobb 3-inch downpipe and a Greddy Ticey exhaust. The Cobb downpipe has a cat, so we're running a cat. Another thing, we're running a Process West intake manifold. You know, we kind of feel that that's free horsepower. It's one of the reasons why we make pretty good power on really low boost. I'll get into that a little bit more. We're running injector dynamics, 1700 cc injectors, and we have a flex fuel system. We're running the Cobb system, which is currently not being sold, but Cobb will bring it back on the market pretty soon. I think they have a 49 state version on the market already, and the 50 state version is pending. It'll probably be out real soon. If you don't want to run Cobb, there's a lot of other companies that make flex fuel systems. To handle like some of the potential blow-by and oil spinning, on top of all the other precautions we've done, we're running a IAG air oil separator. For daily driven street cars, we really like the IAG unit because you run coolant through it, so it helps get rid of all that milkshake in the oil. So it'll help vaporize the water and send clean oil back to your pan. It also has a centrifugal separator, so when the blow-by goes in there, it gets shot onto the wall at an angle, so all the vapor will go out and the oil will stick to the wall and drip back to the bottom and go back into the pan. It's also a really big capacity. I think it's the biggest air oil separator I know of for these cars on the market, which really helps when you're on the track and putting a lot of blow-by through there. For ignition, we're running Ignition Projects multi-spark coils. These coils have about twice as much spark energy as stock, and they do multiple sparks. So at low RPMs, they fire the coils about 7 times, so you have a lot of chances to ignite the mixture. So this is really handy when you have big cams that are wanting to lope and 8-stroke and stuff. It's one of the reasons why this thing idles pretty smooth for how built the engine is. When we were going through the motor, we replaced every single bit of rubber and plastic that could possibly get brittle. We also changed the power steering pump and alternator. We went through the wiring harness and everything that even looked like it might be getting brittle. We replaced iWire, makes like a lot of connectors and goodies, and you know, it's a good source when you're repairing your wire harness. The wire harness was in pretty good shape on this car, but typically they're not. We replaced a lot of connectors and things anyway, the ones that are known to fail and get brittle. So, you know, everything is totally nice under the hood, and a lot of those things are stuff that fails on these Subarus that cause problems. For our fuel plumbing, we went to all Earl's braided stuff and AN fittings. We're running IAG's fuel pressure regulator kit. We're running a Fuel Labs big pump in a radium fuel hanger in the gas tank. The radium hanger has a little surge tank, and it has a higher volume siphon jet, so it helps get the fuel out of the saddle tank really well. Really recommend that. We did a video on how that's all cool, so you might want to look at that. We have an iWire wiring kit and iWire controller. The controllers and the wiring are kind of known to be flaky on these cars. When you're going to big fuel pumps, iWire makes a really good kit to get rid of the skinny wires and all that, and make sure your pump gets a solid 12, 13 volts and puts out what it's supposed to. So that's all by iWire. We also have a iWire wideband kit. So, you know, we have full-time wideband air-fuel ratio monitoring on the car, which really helps with tuning. That's another neat thing that iWire has. We also have the iWire stuff to convert to the speed density. So, iWire is kind of your one-stop shop for any kind of wiring things in these cars. Everything's top-notch, high quality. Totally recommend that stuff. So for cooling, we're running a CSF, their big radiator. This thing probably has about twice the capacity of stock. We're also running a Greddy oil cooler. We like that because it has a thermostatic control, which you probably don't want in a race car, but for a daily street car, that's good. We had our friends at BD Engineering design a scoop and some ducting for the oil cooler, so you get a nice straight supply of cool air feeding it. It also looks really nice down there. It looks just like an OEM part, so they scanned it and did a 3D printed part, and it looks like something the factory did. For an air intake, we're running Cobb's air intake. It's probably a little bit small for this motor, but I don't know, it integrates nicely into the engine compartment, and we think it looks cool. We're also running a Synapse compressor bypass valve, and it's recirculated, so you don't hear all this whooshy, ricey noise that some people like, but we don't. So for an intercooler, we're running a Greddy front mount. This might not be the best cooling or the biggest intercooler. It's kind of slightly small for the power output we're making, but what I like about it is it's a tube and fin. Now, most intercoolers on the market are bar and plate, and these probably actually cool better. They're also actually good as heat sinks, so for certain types of driving where, like drag racing, where you have to do a burnout and do stuff with low airflow, the thermal mass actually helps you. But when you're like doing a track day, what I like about the tube and fin is as long as it has a lot of airflow, it cools really well. And it also lets a lot of air go through the core. And that's important because your radiator needs air also to keep things cool. So the core is also like a lot lighter than a bar and plate. So it's lighter. As long as it has air motion, it cools well, and it lets air get to your radiator. Now, if I wanted to make a little bit more power, I probably would have gone to a bigger bar and plate. But for our all-around use, I kind of like this Greddy unit. If I wanted to make some more power, I could probably make bigger charge piping on the hot side of the intercooler and make a bigger air intake. But our engine makes 520 wheel horsepower and 507 foot-pounds of torque, and to me that's pretty good. To me, it's right in the sweet spot of the motor. I think with some charge pipes and so, like a bigger filter on the air intake, we could probably get, I don't know, another 20 horsepower out of it, maybe a little more, but I'm kind of lazy, and who cares, and it's good enough. With a little bit of bigger charge piping also will kind of make the transient response a little bit less good, so there's some trade-off. I think everything packages nicely how it is, and I don't feel like fabricating a bigger air box or doing anything more, but if I wanted to be king of the street, or if I was actually racing this thing competitively, yeah, maybe I would do it, but to me, 520 is good enough. Which is another kind of cool thing. Like this engine's very efficient, so the way we have it tuned is that the boost peaks at 25 psi and then falls to 18 as it hits the very top. This is pretty low boost. It's almost kind of like a stock FA engine. So we make all this power without much boost, so that's less stress on the motor. Sure, I can get a rotated mount turbo, turn the boost up, or even turn the boost up on this, but like why stress the motor, any more than you have to. Like to me, 520 is pretty scary on the track. So, I'm not a pro driver, but that's all the power I can use. 520 is pretty damn fast on the street too. So one of the things we did to ensure the durability and strength of this engine is we made extensive use of cryogenic treatment. We use CTP cryogenics, and we just about cryogenically treated the entire motor. So we did the block, heads, crank, rods, and pistons, even the bearings and the valve springs and things we cryogenically treated. We also used WPC treatment on the engine cases, the crank, the rods, the cam followers, the cams, the springs, the retainers and keepers. Anything that rotated or rubbed, we also WPC treated. We've talked about WPC and cryo treating a lot. We have videos that go into what they are in detail, so you can do a search on our YouTube channel or go to MotoIQ.com and do a search, and there's a lot of material. Quickly, cryogenic treatment acts like stress relief, and it also does some conversion of the metal. Like if it's a ferrous metal, like it'll go from like an austenistic structure to a martensitic, so you're going from a face-centered cubic crystalline structure to body-centered cubic. This gives better wear characteristics and better strength. This is no BS, and it's real metallurgical stuff that happens with cryogenic treating. WPC is a microfinishing process. The surface is bombarded with really small ceramic balls that are perfectly round. They're mixed with dry film lubricant, and that kind of acts like shot peening, so it forms a really thin, really hard compressed layer over all the surfaces that's slightly dimpled. This dimpling helps retain oil, and the hard skin really improves fatigue strength and also reduces friction quite a bit. So the wear and durability are improved a lot. So we also have a lot of info about WPC treatment. It probably doubles the wear of things like your piston rings and your pistons and your cylinders and your camshafts. I would say it easily doubles the wear. If you're running a low silicone 2618 piston like we are for holding up to turbo boost, 2618 is a lot stronger and tougher than your hyperdetektic cast piston, but it wears quicker because it's softer and more malleable. So strong isn't the same as durable in the case of pistons. So these pistons might only last 100,000 instead of 200,000 like your stock pistons will. But with WPC treatment, they can last a lot longer. So, it's a little bit of a extra cost thing that we do on our motors, but it's an option, and I highly recommend it, especially for a track-driven daily driver kind of car. So there you go. So for the tuning on this engine, Church Automotive Testing did all our tuning. They did a really good job. When we did the power tuning, it was actually like on a record hot day for our area, and it was 105 degrees in the dyno room. So probably our 520 horsepower is like really conservative. If we had even a halfway normal day, it would have made a lot more power. But we wanted to be worst case. Like our tracks in Southern California, they're all at Willow Springs in the middle of the desert, and Buttonwillow, and it gets hotter than hell out there. I mean, you could easily be at a track day where it's 100 plus degrees out in our locale. So, what the heck? We didn't try to get hero numbers or anything, but we tried to be very conservative. Like I said, we're not running as much boost as we could be. We're not running as much timing. We did multiple pulls back to back to back. and we had 0 knot count. So pretty confident our tune's going to be really good. Sean at church, he did spend a lot of time, and he worked the drivability and cold start and all that. A lot of you guys that have flex fuel cars, especially with big injectors and all that, you know they can be kind of a bitch when they're cold. But this thing has pretty flawless cold start and cold drivability on ethanol. It also, even though it has fairly healthy cams, like very little lope, it has a little bit of a rumbly idle due to the cams, but you know, no lope and no jerkiness and anything like that. I mean, it kind of drives like a stock car. Stock amount of turbo lag, no herky-jerky at low RPMs, stock-like throttle response. It's all pretty good. Sean also programmed in a little bit of mild anti-lag and no lift to shift and launch control with a little bit of mild build boost on the line. So, you know, we didn't want to fry the CAD, and we didn't want to have like kind of like annoying crackle tune kind of sounds coming out of the car. So, you know, we have a little bit of that. It's all functional and it's not obnoxious. So, you know, a lot of, I guess the big fad now is crackle tunes and pops and bangs, but, you know, we think that's lame. You know, it's better to have an actual fast car than make all that noise, unless you're on the track. But, so this thing has, you know, like the bells and whistles of flat shift and launch control, but without any of that stuff. We also have like 3 levels of maps. So we have our normal 520 horsepower map. If it's a really hot day at the track, we have kind of a thermal management map that limits the boost by about 4 pounds. We're still at about 450 horsepower on this map, so it's still plenty fast, but you know, it's like if you're having problems keeping the motor cool, this will do it. And we have one even lower level of map, which is about 430 wheel horsepower with even lower boost. So if you're at the track and it's an exceptionally hot day, and your temperatures are starting to creep, which can happen even with all this good stuff, you can always go to lower map levels and keep driving. So, you know, even at 420 horsepower, this thing's pretty damn fast on street tires and no aero or anything. So it's all good. Some of our video might jump around and I'm wearing different clothes and stuff, and it's kind of because we shot it over maybe 6 months and stuff as we were finishing and refining the car. But the car is pretty much where we want it, and we're not probably going to change anything more with it. You know, like if I get motivated, I might change the hot side charge pipe to a bigger one. I might fabricate the Cobb intake box. I might make the box bigger, higher volume, move it this way and run a bigger cone filter. Maybe get some cold air, make a similar scoop for the oil cooler on that side and direct the cold air straight into the box. I don't know, the car's pretty good right now, so I'm not exactly motivated to do that, but those are refinements that can get a little bit more power. We spent a lot of time getting the details, like the top mount water sprayers. We reconfigured them and hooked them up so the front mount gets water spray controlled by the factory controller. We're running a anti-gravity lithium battery in a Melee battery box. This battery is pretty amazing. I mean, it has more power than the stock lead acid battery, and I think it weighs 3.5 pounds or something. I mean, you pick it up, you can pick it up with one hand and it weighs nothing. So it takes about 40 pounds off the front end of the car, and that's a feelable difference in handling. You know, it's probably better to do this and have short wire runs than to mount a battery in the trunk. We think it's a pretty cool thing. The melee battery box protects the battery in a crash and holds it securely, and has quick release pins so you can take the battery out real quick. Since we're running the Process West intake manifold, there's no provision to put the factory surge tank in there. And I kind of think a surge tank's really important to get rid of the bubbles and things out of your cooling system. You know, the stock Subaru factory one's really good, but what we did is we got the IAG surge tank that bolts to the shock towers. It's mounted a little bit higher to help get the bubbles out a little better, and it's a little bit higher volume. So we're running the IAG motor mounts and the IAG torque arm. These have hard urethane bushings, and they really prevent the motor from moving around very much. When you have a four-wheel drive and you're launching, you put a lot of stress on the motor, and you don't want the motor to twist around. You know, this could contribute to wheel hop and, you know, just generally breaking things. We were worried that the IAG mounts were going to be like vibration and noise monsters. You know, our experience with some Nissans and Hondas, they're pretty sensitive to how hard of a motor mount you have. But surprisingly, you can barely tell with these things. I don't know if it's a characteristic of how the motor shakes, or if IAG has some secret sauce in their motor mount formulation, but these tiny bushings that are made out of hard plastic really don't transmit that much noise and vibration to the inside of the car. Sure, you can tell a little bit. It's not perfect, but it's actually pretty darn streetable. I think we talked about it in other parts of the video. We have white line transmission mounts and white line diff mounts, so everything's held in pretty solidly and to reduce wheel hop and stress in all the parts. For a clutch, I really like the clutch we're running. We're running a X-Clutch twin disc. It has twin organic discs, and this clutch is designed to hold like you know, up to probably 650 horsepower, but literally it drives like a stock clutch. Like, the pedal effort is only a little bit more than stock. The engagement is smooth and maybe even smoother than stock, and it doesn't judder or anything. The only indication that you have some kind of serious clutch in there is when you push the clutch in, you get the typical twin disc ringing of the center floater. So you hear that ringing a little bit, but that's the only indication that something that's not stock is in there. So if you have a hot Subaru, I really recommend this clutch. You know, like having the organic discs and all that, and the softer engagement is easier on your transmission and the rest of your drivetrain. So I really recommend this on a street-driven car over the Super Trick puck type clutches. Another thing about the clutch is Subarus are really sensitive to throwing multi-cylinder misfire codes, and if you get a light flywheel, like a really light flywheel, it'll pop that code all the time. Like, a lot of you guys have race cars, you probably don't care, but it's really important that if you want a light flywheel, that it's not too light. And the X-Clutch is just the right amount. Like, the flywheel is lighter than stock, but it's not so light that you're going to be popping those multi-cylinder misfire check engine lights. It's really important when you have cams like this car has, which idle a little bit on the rough side to begin with. So this is one of the best clutches that's going to be the least amount of problems, especially if you're on a stock ECU. I guess for our tuning side, we talked about Church Automotive Testing doing the tuning. He tuned an Ecutech. We use a access port to monitor the engine conditions, Cobb access port. So yeah, that's it on the engine side. Like I said, you know, we're not trying to be the fastest in the world, but we want to have the fastest, most reliable, daily driven reliability. You can pound it on the track. You can actually do a track day, you know, conservatively tuned. really friendly Subaru. And I mean, if you guys haven't driven a 500 plus horsepower Subaru, you know, once you try it, you'll have a lot of fun. I mean, sure, it's not 800 horsepower, and you're not going to be the absolute king of the street, but I can tell you what, there's not too many cars that can run away from a STI with a 520 horsepower. A lot of you might wonder why we picked the 2005 GD to build. I kind of feel like it's the best of the GD type bodies. So when they launched the car in 2004, the 2004s have some problems. One of the things is that they have an odd bolt pattern on the hubs. It's 5x100, and there's not a lot of choices for wheels. In 2005, they went to 5x114, which is one of the most common bolt patterns, so it really opens up your choice of wheels. The other thing is the 2004s with the tighter bolt pattern hubs, their hubs were weaker and with a smaller bearing system. So that means, like on the track, with a little bit of wear, everything would start to flex and you start getting knockback in your brakes. What this means is when the hubs start flexing and develop play, the rotor kind of wobbles around and it pushes the pistons back into the caliper. So you're at the track, you're driving around, you come into the turn, you hit the brakes and the pedal goes to the floor, and you have to pump it to get it back up. Now, you know, I don't know about you, but to me that's pretty scary. So Subaru in the 2005s went to a bigger, stronger hub to reduce that problem. The other thing about the 2004s is the steering rack is kind of like secured with clamp-on bushings. So what happens is when you put big sticky tires, the steering rack starts moving back and forth in the bushings. When this happens, your steering centering changes from turn to turn, and your steering feel's not as good. In 2005, they mount the rack so it has small bushings bolting straight to the cross member, not bushings going around the rack, clamping to the cross member. So the 2005s and later have a lot more positive steering rack mounting. The other thing, in 2006, the car went through a lot of cost down things. So the car is cheaper. They did things like, instead of forged suspension links, they went to stamped steel from the WRX. And overall, generally, the car, wherever they could take money out, they did. So we kind of feel that the 2005 is the best starting point to build one of these things. Another thing we spend a lot of time on, considering that this is an older car, is improving the chassis stiffness. So, you know, we have undercar bracing, subframe connectors made by Cusco. We also have a Cusco strut tower brace, and we have a bunch of bracing in the trunk, all Cusco stuff. We have Ultra fender braces, which actually made the biggest difference of all the braces. These things bolt to the door hinge bolts and extend to the shock towers and reinforce that part of the car. And actually, the Ultra braces probably made the biggest difference in them all. But the braces really improved the ride comfort, the NVH, and overall the response of the car. You know, newer cars, they have much more stringent crash standards, like the narrow offset barrier and all that. And newer cars are a lot stiffer than these old ones, so you know, the braces aren't as big of a thing. But you know, they're a night and day difference on these old cars. So doubling the power means that you better be increasing your braking power quite a bit. The stock Subaru brakes are Brembo, and they're pretty darn good, but when you're cramming double the amount of horsepower in a sort of a heavy car, more brakes is always better. So what we did is we used StopTech's Trophy Kit. This is a really outstanding brake system. It uses a 355 millimeter rotor with a big 6-piston caliper. Unlike StopTech's regular system, the trophy kits, all the excess material is CNC'd away, and everything is hard anodized instead of just regular anodized and powder coated. So they're not going to burn off or change colors. With all the CNC paring down, the whole system weighs about a pound less than the regular StopTechs. Why we like StopTech is because they have, like, I think 30 something different piston sizes that they can use in the caliper. They can exactly match the hydraulic proportioning that you had in your stock brakes. So what this means is things like your ABS is going to work correctly. Now generally aftermarket brake systems, they only have like maybe 3 different size combinations of pistons for your caliper. So sometimes you have a long squishy pedal, or the ABS is over biased, so the ABS is going to come on too early. That stuff's really irritating, and often with some kits your brakes work less well than stock. But when you're running the stock hydraulics, the stock electronics, StopTech matches everything perfectly. If you have a newer car that has ABS and electronic force distribution and stability control, things like that, they'll still work perfectly with StopTech because as far as the car sees it, it's the stock brakes, stock proportioning. So that's why we love StopTech so much for OEM applications, stock hydraulics, stock electronics. The StopTech rotor is full floating, so that means it can move around with about maybe 18 thousandths of play. What this does is it prevents cone type distortion. Like a regular rotor, because of the thermal mass of the hub part, the rotor kind of distorts like a cone as it gets hot, and that causes a mushy pedal and unequal pad force distribution. Generally, you only see this kind of thing in track use, but it's definitely something you can feel. The floating rotor eliminates that. The floating rotor is also a little bit more forgiving to piston knockback if the bearings start getting loose. That's another good thing. The disadvantage to floating rotors is when you're driving around on the street, they make like a ringing noise that can be kind of annoying. But StopTech has addressed this. They have like some Inconel washers that you can't see on the backside that put some preload on the floating rotor, so it's not free to clank around so much, but it could still react to the heat distortion and still moves around freely enough. So that's another cool feature. You get the positives of a floating rotor with not the irritating noise. Finally, the StopTech caliper has a bridge in it. This big bridge prevents spreading with the hydraulic force when it's applied, and that assures that you have a really firm pedal. And I think in benchmarking, StopTech had one of the stiffest calipers on the market, so you get a very good pedal feel, very direct. StopTech kit comes with braided steel lines, and we're running their 304 compound in there for the brake pads. 304 is kind of like high performance street. What's good about having big brakes is you could run a streetable pad on the track. Now, you could probably run the stock brakes on the track, but you would have to get a very aggressive pad, and that kind of pad would wear out the rotors really fast on the street when it's not coming up to temperature. So you have to change the pads when you get to the track and then when you leave, and that kind of sucks. Bigger brakes, you can run a streetable pad, like run on the street, run on the track. The 304 is pretty good. It doesn't make too much dust, and it doesn't make like squealing noise or anything, so it's kind of a good overall pad, and you can get away with it due to the bigger thermal mass of the bigger brake. For our suspension, we used KW Club Sport 3-way shocks. Now what's cool about the 3-way Club Sports is the damping is adjustable 3-way. You have your low speed and high speed compression independent of each other, and also you have your rebound adjustment at the top, all independent. High speed controls like how the car hits bumps and responds to big hits. Low speed controls like body motion, like dive, squat, and sway. And rebound controls like rebound, like how the suspension unloads from bumps and things like that. The ability to adjust these independently gives you quite a bit of flexibility. Now, in this car, we did it for kind of like cosmetic reasons because we run the car pretty low. That's purely for looks. Like if you're into total performance, we don't recommend you running the car as low as what we did, but we think it looks cool. So when you run the car low, you don't have that much bump travel. So we up the high speed to keep the car from bottoming out. It's pretty cool. It enables us to get away with that. The car is a little bit more nibbly over the bumps, so if we're actually going to be racing this thing for competition or want a little bit smoother ride, we probably would set the ride height about half an inch higher and kind of back off on the high speed adjustment, but we want to look cool. That's really important, you know. Some of the other things is the Club Sport has a stainless steel body, so it's kind of all weather, all climate kind of thing. It's not going to corrode. And it has a stainless steel plastic covered spring seat. Now this thing is not going to corrode. You can drive it in a salty winter and your spring seat's not going to seize onto the shock body, so it'll be easy to adjust no matter what. I think that's a really good feature. I mean, if you mess with coilovers, you drive them in the rain, drive them over the winter, and man, these things can get stuck, but not at KW. They also have a limited lifetime warranty, so if they ever go bad, you can send them back and KW will fix them. Some of the things we did that's a little different is instead of the KW camber plate, we're running a Vorschlag camber plate. We like the Vorschlag unit because it has a 1/2 degree of caster offset built into the plate. We wanted to run more caster. The Subarus don't have very much caster stock. I wanted to get about 6 degrees, so this thing brought it up to about 5, and then we used some white line bushings to get it up to almost 6. So more caster, more straight line stability, kind of more initial turn-in bite, because as you turn in, the outside wheel goes to negative camber, so the tire digs in a little bit better, and overall a good thing. You don't want to overdo caster, but for this width of tire at 245, 6 degrees is about right. So for some of the undercar suspension stuff, we did kind of a lot of things. First off, we replaced all of the bushings with White Line's polyurethane. We used the black ones, which are stiffer than the yellow ones. In hindsight, maybe we might have used the yellow ones, but the ride's still not that bad. We have White Line's roll center correction kit. What this does is it moves the control arm pivot down, so the roll center is restored on the lower car to pretty close to stock location. When your roll center gets too low, your roll moment gets bigger, and so the car actually has a higher propensity to roll in corners even though it's lowered. So this corrects that. When you lower this pivot, you also have to lower the tie rod pivot or you get too much bump steer. So this actually has White Line's bump steer correction kit. We'll probably do other videos and get more into geometry correction and suspension geometry and what makes it good, but I'm not going to dwell on it too long here because this is just a car overview and some of the things we did. We also have White Line's anti-lift kit. Now they call it an anti-lift kit. I call it anti-dive reducing kit. The stock Subaru has like a lot of anti-dive geometry in it. So what this means is when you hit on the brakes and the front of the car wants to dive under braking, the suspension actually uses that braking torque to create an upward reaction force to resist dive. This way they can control nosedive under braking without having to resort to really heavy springs and stiff shock valving. But guess what? We got coilovers now, so we have stiffer springs and more shock valving. What happens is that when you have a lot of anti-dive, it gives some unpredictability in the car's handling. Like it makes it like less linear. So when you're braking, you're actually adding kinematic bind into the front suspension. So the bind is actually making it resist movement, so it actually makes it stiffer. So as you make the front stiffer, you tend to get understeer and even wheel hop under acceleration, because this is a four-wheel drive car. So when you're trail braking to try to transfer weight forward to reduce understeer, you're actually increasing your front wheel rate and you're increasing your propensity to understeer, while your weight transfer trick is trying to reduce the understeer. That makes for non-linear handling and makes the car kind of harder to drive quickly. But what we're doing is we're actually making the lower control arm more parallel to the ground. And when you draw the force vectoring, you're getting rid of a lot of that anti-dive. So now the car will respond to trail braking in a much more predictive manner, and it reduces its tendency to wheel hop under acceleration. Another thing that the anti-lift kit does is it moves the suspension pickup point in the back outward, so that kind of kicks the wheels forward, and that gives you more positive caster. So between this kit and the Vorschlag camber plate, we now have almost 6 degrees. That's up from the stock 4. So the car turns in nicer, and it also has better straight line stability going down the freeway. Kind of the best of both worlds with no negative trade-offs. We changed the anti-sway bar in the front to Whiteline's big anti-sway bar. So this is 25.4 millimeters. It's about 4 millimeters bigger than stock, I think. I can't exactly remember off the top of my head, but it's something like that. So it's quite a bit stiffer than stock. It's also two-way adjustable, and it has adjustable end links. This way, when you're corner weighting the car, you can disconnect the end link, do your corner weighting, and then reconnect it, but dialing out all the preload that the bar might have that would mess up your corner weighting job. So that's a pretty cool thing. If you notice, we also have like a lot of Cusco under chassis braces. This being an older car, the chassis flexes a lot more than like the late model. So our steering rack uses white line bushings. The white line bushings are stiffer and totally prevent the steering rack from moving, so you get a lot better steering feel, a lot more direct, and gets rid of all the mushiness in the steering. So while we're underneath the car, we can talk a little bit more about our engine stuff. I mean, super obviously, you can see our front mount Greddy intercooler, our CSF radiator. You can see our equal length MXP header right here and MXP up pipe. You can see our Greddy oil cooler with the thermostatic housing. Oil cooler actually is over here. You can kind of see it, and you can kind of see the ducting if you look in there. You can see the valve covers we're talking about, and if you look really closely, we have Ignition Project's multi-spark coils. These coils are pretty cool. They have about 50% more ignition power than stock. They also spark the spark plug multiple times per firing cycle, so you have a lot of opportunities to light off the mixture. And then these really make a big difference. I mean, we use it on our drift cars, time attack cars, Pikes Peak cars, and it really helps improve ignition reliability, gets rid of the misfire. We can run a bigger plug gap. They're a really good deal, and you get all this ignition performance increase by just changing the coils, so it's easy too. No brainer. You can see the IEG big sump oil pan. What's cool about it is it doesn't hang below the cross member, so even though it's high capacity, man, if you smash this sucker, you've probably done worse things to the bottom of your car. So looking at the exhaust, we're running a Cobb 3-inch downpipe. It's a beautiful single piece mandrel vent piece with like seamless. It's really cool. The part where it bolts on the turbo is like investment cast stainless, so you're not going to have any warping. And there's plenty of area for the wastegate discharge to flow with minimal impingement on the turbine flow, so it's a super nice piece. We have a Cobb adjustable short shifter, really positive feeling. It can be shorter throws. Right now we have it so it throws the same as stock, so we don't put any more stress on the synchros. We're just enjoying the better shift feel. You can see some of the Cusco under chassis bracing here. The exhaust is a Greddy Tie C. It's a 80 millimeter tube, and it's really free flowing. It has straight through absorption type mufflers, and surprisingly it's not that loud. I mean, this car is a little louder than stock, but it's not ridiculously loud. So going to the rear, our rear suspension, we're running the KW 3-way Club Sports just like the front. Our shocks have a Race Comp Engineering camber plate. That's because you don't have a lot of camber adjustment in the rear without it. The back, we're running White Lines adjustable links. These have stiff bushings, and you can adjust the track, which is somewhat your camber, but mostly you can adjust track so you can get your tire fitment really good. Especially if you're one of those hella flush guys, which we're not, but we have full camber control. We have white line bushings in the trailing arm, so all our bushings are stiffer. One thing about these Subaru rear ends is that they tend to bind if you go too crazy with your bushing stiffness, so kind of recommend that you stick with the white line yellow bushings in the back. Maybe you could put a black one in the front, but I would run yellow here, 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 and here to reduce that bind. I guess if you wanted to spend a lot of money and you didn't mind some additional harshness, if you go all spherical bearings, that's another way to get rid of the bind. And you'll actually find like an improvement in ride, but more vibration will be transferred to the cabin, so it's kind of a trade-off. We're running the White Line bigger 24 millimeter rear sway bar. It's 3-way adjustable, and most importantly, it has these heavy-duty mounts. Now the stock Subaru mounts are really weak, and when you put a big bar like this, they tear right out of the chassis. White Line replaces this with a really strong aluminum extrusion that's not going to distort or tear. So we shot some of the last video. We didn't have our rear brakes yet, but we're doing some track testing and stuff, and we felt that maybe the car would do better with more rear brake. Trouble is, not too many people make a rear brake kit for these GD STIs, and we wanted to stick with StopTech because of the proper piston size. So what we did is we got a brake kit from a VA STI, the one generation newer, and we had our friends at BD Engineering design us a bracket to adapt the caliper. The rear brakes are mounted really strange on these GDs. They're mounted really close to the center of the parking brake disc, and they're mounted on the backing plate for the dust cover of the rear brakes. So because of this, not too many companies make a rear brake upgrade. Essex makes a AP rear brake upgrade, and I think some Chinese company makes one too. And you know, I don't want to put any Chinese rear brakes on this car. And the Essex one is nice, but we like StopTech's piston sizes. So we came up with our own MotoIQ rear brake upgrade for this. So basically this kit uses an ST22 two-piston rear caliper and a 135 millimeter rear rotor. Like the front, it's a floating rotor, it has clips, and what's really cool is the hat is designed so we can retain the stock parking brake. So the parking brake is fully functional. It drops about 5 or 6 pounds of unsprung weight on either side of the car and gives considerably more stopping power. So when combined with our front brakes, we've noticed a pretty big difference. The big brakes help us run a non-aggressive streetable brake pad at the track. The stock brakes in these cars aren't too bad, but for track use, they're going to come up a bit short unless you change to a more aggressive track type compound, which really sucks on the street. Like a track type brake pad will dust like crazy and chew up your rotors really quick in normal street driving. So with our big brake system, we can have a pad that'll work good for street, and the brakes are big enough to have that kind of pad on the tracks. So, win-win situation here. Plus, it looks cool as hell. I mean, I guess that's an important thing too. So for wheels and tires, we're using Advan TC3s. This is a pretty good wheel for the price. It's one of those semi-forged wheels, so it's a high-pressure die casting that has the wheel rolled out on a roller in cold work for the barrel section. So the rolling actually produces a nice grain structure, almost like forging, in the part that's really stressed for a much cheaper price. So it's not as trick as a fully forged wheel, but it's kind of like a little bit more expensive than cast and has much of the benefits of forging, being strong and light. The wheel is a 18 by 9.5 with a 35 millimeter offset, and we're running a 245 3518 Falcon. Right now they're 615s. As soon as these wear out, we're probably going to put some 660s on here. Really good, long-wearing, all-around tire. With this wheel, we get a really tight fitment. If you don't do anything to your fender lips, you're going to rub if you're running a similar offset, but we're able to get rid of the rubbing with just a light trim of the inner fender lip. We didn't even roll it. We just trimmed it a little bit with a little standing wheel, and we have a pretty tight gap here, no rubbing, looks really cool. So if you wanted to duplicate that, that's the size wheel and tire we used. So the Subaru powertrain moves around quite a bit. Stock, the bushings are like made out of this really gushy rubber. So the diff moves around, the tranny moves around, the motor moves around. This contributes to wheel hop and juddering. Sometimes the wheel hop can get really bad. This breaks components and stuff, and it messes up your traction. So what we did is we used white line bushings. They're solid high durometer, I think like 90 durometer polyurethane bushings to mount the diff, mount the cross member, and we're using IAG heavy duty motor mounts for the tranny and the engine. Now, normally this stuff causes all kinds of extra vibration and noise. We didn't notice any increase in NVH at all with the differential and subframe bushings. The IG motor mount and transmission bushings maybe make a slight amount of more noise and vibration, but it's really hard to tell. I mean, we've had Project Hondas and Nissans where doing a stiffer motor mount really makes things vibraty and noisy. But the IG mounts, even though they had tiny, small bushings, we thought for sure they were going to be really rough. I mean, you can hardly tell over stock. Maybe you almost can't tell, but being really picky, it's a slight amount of vibration and noise more. But best of all, it gets rid of all the wheel hop. A really important thing we did is we used white line subframe locks. Now the stock Subaru subframe under cornering load and even launching at the drag strip can move around like an inch in all directions, believe it or not. But white lines actually measured this with dial indicators and stuff, and man, that's a crazy a lot of movement. It makes the handling twitchy. So what we've done is installed white line subframe locks. They go right here and right here. And what this is a shoulder bolt that threads into like a stock unused hole in the chassis through the subframe. And what the shoulder does is it completely locks the subframe and keeps it from moving around at all. It's a really cheap part, really simple, but it really cleans up the handling. And not too many Subaru people talk about it, and I suspect not too many Subaru people know about it. But it's a quick, cheap fix, really effective, and doesn't break the pocketbook. It's one of the cheaper things you can do. So before we close, let's take this on a quick test drive. Okay, so let's go on the test drive. The car's been cold soaking for a while, so let's see how it starts and runs on ethanol from a cold start. A little bit longer crank than gasoline, but not bad. Idle's nice and stable. You know, not too bad at all. Let's roll out and see how she does. So that X clutch is really smooth. You might be able to hear the ringing of the floater plate a little bit, but it's really not that much. That's the only hint that this isn't the stock clutch. Now, driving around, the pavement here is terrible. I mean, this is LA, and they never fix anything, and it's almost like a dirt road. And when they do fix it, it's not that great. Now, the ride's definitely firm, you know, but it's really not that much worse than a stock STI or an Evo or something, or any sports car. I mean, one of the great things is the handling on this car. Now, this is like an industrial area. Pavement's really bad, but the ride is actually pretty pleasant. This car is probably lower than optimal, and to keep the car off the bump stops, you know, we're running a little bit more high-speed compression than is probably optimal, but it's still not that bad. You know, if I wasn't into having this thing look all low and cool, I'd probably raise it up a half inch and back off the high speeds, and you'd probably have some ride pretty close to stock. But the handling is really, really something. Now, it's hard to get on this thing with all the traffic around here, but let's try to a little bit. So here we go. Man, this thing is fast. You can get into a lot of trouble. Like, a lot of people might want to run higher power, but really 520 is more than enough. I mean, there's not too probably many cars at the factory that could keep up with this thing. You know, it's kind of scary on the street around here with all this industrial traffic and people going in and out. You know, being where we are, the skill level of other drivers and the predictability of them isn't that great. So I'm trying to be careful and still show you guys. Yeah, it's really hard to get on it very much. You can only do full throttle for a few seconds. Yeah, at this hour, the traffic on the freeway is bumper to bumper. Not exactly safe to do too much here. Wow, here's a guy about to pull out right in front of us. He had to hit the brakes. Oh well, maybe that gives you a little preview about how good this thing runs. But Yeah, sorry, can't do a better thing for you guys with all our traffic. So that wraps up our take on how to build a Subaru. You know, built correctly, they're not bombs. They can be really fast and really reliable. Our Subaru here, I kind of like to think of it as if the Subaru factory wanted to build a supermodel, this would be it. You know, basically, we tried to even make it look relatively stock. We tried to pay attention to the ride comfort, the engine drivability characteristics, not make the most power in the world, but have the best drivability, durability, good solid brakes, and try to avoid squeaks and rattles and things like that. And overall, I mean, this is like a really pleasant car to drive. I kind of call this OEM plus tuning, I guess. So you get all the attributes of a more expensive kind of supercar, but without any of the negatives associated with it. So, you know, if you like what we did, want us to mess with your Subaru, you can go to MotoIQ.com, our website. You can check on the garage services, and we can get back to you. There's tons of Subaru tech content on MotoIQ.com if you're so inclined to read. I know reading is a big stretch to ask from people nowadays, but yeah, you can read all about it. We also have we're going to put all our Subaru content into one place on our YouTube channel, so you can look at all the Subaru stuff we have there, all our videos. So just, you know, look at our YouTube channel. It'll be easy to find. We'll organize it like that. If you want to get our merch, you like my cool MotoIQ hoodie and shirt, we have that and a few other ones that don't say MotoIQ all over them for sale in our web store. And we also have a lot of the parts that we talk about here for sale in our web store too. So if you buy our stuff, it helps support us and helps us roll out more and more content. So I hope you enjoyed this video. I hope I explained that, you know, Subarus aren't total piece of the junk, and you can build a pretty nice one. So until next time, I guess we'll be talking to you.